Hi, my name is Sean Walsh. I am a Senior Principal Support Engineer with CA Technologies Technical Support. Today we'll be talking about CA Service Desk Manager and Microsoft SQL Server Performance. CA Service Desk Manager solution uses Microsoft SQL Server as its backend database. It can also use Oracle, but today we'll be focusing specifically on Microsoft SQL Server. At times, SQL Server might be slow in returning results back to Service Desk, and this can greatly affect the performance in the application. To troubleshoot those types of issues, support has written a document TEC 580653, which is a very useful document covering various CA diagnostic and Microsoft diagnostic tools that can help us and help your DBA find the root causes behind these slowdowns. I should say that this video is not a substitute for feedback from your database administrator or from Microsoft documentation. One of the more frequent complaints you'll get is that searches are slow. This could be because SQL is taking a long time to return results back to Service Desk. If you navigate to the Service Desk log files, you may find messages like the following. That state the following statement is taking 1,870 milliseconds to return results. Sometimes it can be substantially more than that. By default, Service Desk will print out anything that takes 1 second or longer to get a result back from SQL. Here, I have taken the SQL statement I found in the log files and I formatted it so that I can run it inside SQL. So I'm going to do that now. I'm going to come over to SQL, open up a new query window, and paste in my query. Some things I want to do is I want to get statistics on where the query takes time to run. So the first thing I'm going to do is go to the query menu and include the actual execution plan, include client-side statistics, and with both of those options selected, I should get a pretty good idea of where the bulk of the time to resolve that query takes. So now that I've selected both of those options, I'm going to select Execute. As you can see here down the bottom, it says Query executed successfully. Now I've got several tabs. I have the results. In this case, I don't have anything. Messages. And here I can see where it spent the bulk of that time processing that query. I can see that there was an index scan on this particular index, callrec x0. So I know that 26% of the time was spent there, and another 73% was spent on the on this index, the xpk callrec, which might be a primary key index. So using that, I can communicate that to my DBA to maybe understand where I may need an index or something else might need to be added. The last tab here is Client Statistics. This will show actually how long it took to resolve the query. So if I scroll down to the bottom, you can see network statistics, time statistics, client profile statistics, and get a pretty good idea of where the bulk of the time was spent as well. This is extraordinarily helpful for CA support and for your DBA in helping to resolve where these slowdowns might be happening. You may find that many queries are fast and you don't see anything in the log files. However, in some specific cases, some queries take a long time. That usually indicates that you need an index or an index needs to be rebuilt. The document that support has written describes that in pretty good detail. Here we have an example on how you can extrapolate from the logs any long-running SQL statements, and then how you can format that so that you could run it in SQL. Next, it provides the steps to put that SQL statement inside SQL with the appropriate forensics in place, like client-side statistics and execution plans, so we can see where the bulk of the time is spent. Another thing that may happen is the user is doing a search for a specific object, say in this case a CI, And as they're searching for it, all they get is a white screen or an hourglass or some type of CGI timeout that may indicate some type of blocking in SQL. So I've extrapolated that query here, and I'm going to run it just to give you an example. I'm going to execute that. And as you can see, it's executing it, but it never comes back with a result. So it'd be interesting to see where that is getting blocked or why that's never coming back with a result. So the first thing I can do is run a procedure in SQL called SP-who2. I'm going to execute that. And if I pay attention to the blocked by column, what I should see is that the select statement I'm running is being blocked by a SPID of 54. So to find out more, I can look at here, I can look down at 54 and see what that is all about. Or I can get more detail from the activity monitor. So I can come over here to the activity monitor. And to get to the activity monitor, typically I would be in the Object Explorer. I would right-click the server name and I would say Activity Monitor, as I have done here. So I know 54 is the bad guy, right? He's the one doing the blocking. So I see him here in the list. I can get more information. I can get the details. And here we have some type of procedure that seems to be blocking the other SQL statement from completing. So I can say kill process. And again, don't do this without consultation with your DBA. Now that is gone, so effectively my block should be gone. So I'm going to come over to SP-who2 and I'm going to run that again. And I'm going to look for the block by column, and I've got nothing there. And if I look for the query, I can see it returned results. So the block was removed and it was able to return results. That type of blocking usually is the result of another application accessing the same database table. It could be because of replication. It could be because of a long report. It could be because somebody's doing a job inside SQL, a database trigger. It could be a number of things, but following that process of running SP-who2 to identify who the blocking SPID is and using Activity Monitor to get more information on that blocking ID, we can kind of figure out pretty quickly how that blocking is happening. Another common reason why performance can be slow inside SQL Server is that indexes can get fragmented over time. Our document, again, talks about this and gives an example of a select statement that you could run to look for fragmentation over beyond a certain threshold. In this case, a general recommendation of 30% is stated here, but sometimes even less than that, less fragmentation than that can cause performance issues. So if I were to run this inside SQL, I would get a column average fragmentation in percent, and I'm just going to scroll down a little bit to show you what that looks like. Here I have an example, 26.31%, 33%. These are seemingly very fragmented indexes. So there's various ways that those could be defragmented. However, when doing that, we have to be careful that it's be cognizant of whether or not it's an offline operation or an online operation. Offline operations can put locks on tables and slow things down drastically for the application. Online operations can be performed while the system is up and running. But again, there's pluses and minuses to both. In the document here, we provide a link to a Microsoft article that talks a little bit more about that. Alter index is the way to go typically. It's an online operation, but you'll need to work with your DBA in figuring out the most appropriate way to do that. Another online operation is dbcc index defrag, which can be used, and that we give an example of that here and the Microsoft article. Another important item to consider is the application only uses a limited number of connections to the database. That is configurable. However, if that count is too small, we can have it sort of a traffic jam, so to speak, getting data from the database. There's a utility to check that. It's called PDM_VDB info. That tool can be used to monitor the status of each of those database connections. It can look for idle agents, meaning idle connections, which is good, or pending requests, which can be very bad. That can mean that there's stalls getting the data, and it means generally that we've got a database that might not be responding quickly, or we just simply don't have enough database connections to handle the load. So the document talks in great detail about how to use that and what to do with the results. Don't take it for granted. There is no harm in increasing the minimum number of database agents, but check the document for the considerations in terms of what you need to be aware of in terms of available memory and resources on the application server. The document also has links to other documents which are important for troubleshooting performance issues. Down towards the bottom you can find the link to another tech doc, TEC 473185, which covers how support identifies bottlenecks and causes of performance issues. We also talk a considerable length about architecture and performance in our Service Desk Manager Green Book, and there's a link down there as well. Well, thank you for your time today. I hope that was informative. I would ask that you please take a look at the knowledge document because there's a lot of great content there. And we hope to create more videos for you in the future. Thank you.